Hey everyone, and welcome to The Explainer. Today, we're unpacking what might just be the single most critical section of the entire ISO 14001-26 standard. We're talking about Clause 8.1, Operational Planning and Control. You can think of this as the ultimate blueprint. It's the exact point where high-level environmental theory, all those ambitious goals discussed in the boardroom, finally meets the harsh, practical reality of the factory floor.
It really forces us to ask a super pragmatic question. How do lofty environmental policies actually survive contact with daily operations? Because let's be honest here, without a highly structured operational plan, even the absolute best environmental policies are going to crash the moment production ramps up or a sudden supply chain issue hits.
Okay, let's dive into this. Here is our roadmap for today. First, we'll cover moving from policy to daily practice. Second, designing effective controls. Third, extending beyond internal operations. Fourth, we'll take the lead auditor's perspective. And fifth, we'll wrap up with common operational nonconformances. All right, part one. Moving from policy to daily practice, which is really the bridge to reality. Clause 8.1 is fundamentally about translation. It takes what you want to do and translates it into what you actually do. But before you can control anything, you've got to know exactly what you are controlling. We must identify our significant environmental aspects. We're talking about specific organizational activities, products, or services that can cause considerable environmental impact. Things like hazardous wastewater discharge or heavy solvent emissions. Pinpointing these is the absolute prerequisite for targeted operational control. I really want you to let this quote directly from our source material sink in. Environmental impacts do not arise from policies or strategies alone, but from real operational activities. I mean, it sounds obvious, right? But the stakes are incredibly high. A beautifully formatted, perfectly spell-checked environmental policy manual sitting on a corporate server somewhere simply cannot stop a chemical spill. Paperwork alone doesn't prevent environmental harm. Only controlled operations can do that. And this brilliantly illustrates the dynamic. Think of your environmental policies and objectives as the map. They tell you where you want to go. But Clause 8.1, your actual operational controls, those are the steering wheel and the brakes. They're the physical mechanisms that keep you on the road and actually prevent the crash when circumstances change. Moving right into part two, designing those effective controls. It's time to engineer the controls. So, how do we actually build these mechanisms? Well, we have to ditch the vague intentions and start setting concrete operating criteria. Honestly, if you take away just one thing from this explainer today, let it be this. Without defined operating criteria, your environmental risks remain completely uncontrolled. If you just give an operator vague instructions like, hey, try to minimize waste, you're going to get wildly inconsistent performance. Operators need measurable, repeatable limits to actually succeed. Let's anchor that theory with some concrete examples. If you're in paint manufacturing, an operational control isn't just telling people to store solvents safely. The defined criteria must be a specific maximum temperature limit for solvent storage to actively prevent volatile organic compound emissions. Or, say you run a wastewater treatment process. Your criteria aren't make sure the water is clean. You need specific chemical oxygen demand, or COD, limits, and tightly defined acceptable pH ranges. That is exactly what defined operating criteria look like in practice. But keep in mind, not all controls are created equal. We've got administrative controls, which are things like training, general awareness, and verbal instructions. And then we have engineering controls, like automated shutoff valves and emission filtration systems. The standard heavily favors strong, automated engineering controls. Why? Because relying solely on human behavior is just a massive risk. People get tired, they get distracted, they rush. Engineering controls work consistently, round the clock. Which brings us to part three, extending beyond internal operations into what we call the life cycle perimeter. Under ISO 14001-2026, just checking your own factory floor is no longer enough. The standard absolutely demands a life cycle perspective. This means extending your environmental responsibility way beyond your own organizational boundaries to include suppliers, contractors, logistics, and even product disposal. Your company's true impact includes the entire supply chain. This totally changes how you operate at every single stage. Let's walk through this flow. It starts right at procurement, where you're evaluating and selecting green suppliers. Then it moves into design,
integrating low-carbon principles or recyclable materials before a product is even made. And it extends right through to delivery and outsourcing, where you must actively track compliance both upstream with material providers and downstream with waste contractors.
So what does this actually look like out in the real world? Well, it means evaluating your logistics suppliers strictly based on their fuel efficiency. It means ensuring that contractors on a construction site are actively using dust suppression techniques. It requires verifying that your hazardous waste contractor is actually disposing of waste legally rather than just taking their word for it. And above all, it means the communication of incredibly clear environmental expectations to every single external partner you work with.
All right, let's move to part 4, the lead auditor's perspective. We're going to look through the inspector's lens now.
Let's shift our tone a bit. When audit time rolls around, everyone naturally gets a little nervous. But if you really understand Clause 8.1, you don't need to be. So let's pull back the curtain. What are lead auditors actually looking for when they're evaluating your systems?
Now, what's really interesting about this is that auditors don't just blindly check boxes. They directly map requirements to tangible evidence. If the requirement is documented operating criteria, they don't just ask if you have them. They want to see accessible standard operating procedures right out on the floor where the work is happening. For infrastructure reliability, they're going to demand maintenance logs and calibration certificates to prove your monitoring equipment is accurate. And for implementation consistency, they are literally checking to see if the night shift is executing the exact same way as the day shift. Let's put that into perspective with a specific number: 20. Say your company's boardroom sets a massive environmental objective to achieve a 20% water reduction. Well, the auditor expects to see operational controls directly linked to that specific goal. They're going to hit the floor looking for active leak detection protocols, flow monitoring devices, and maintenance schedules to prove that the 20% reduction is actually happening in reality, not just sitting on a spreadsheet as a wishful target.
And finally, Part 5, Common Operational Nonconformances. These are your major red flags. Lead auditors see the exact same failures time and time again. First up, missing measurable operating criteria. Basically, your limits are vague. Second, what we call orphan procedures. These are those beautifully written documents that sit on a hard drive somewhere but are completely ignored by the actual operators. Third is outsourced blindness, which is just blindly trusting your suppliers to do the right thing without ever verifying their compliance. And fourth, an over-reliance on administrative controls. Simply telling people to be careful instead of actually engineering the risk out of the process. These are the specific red flags that will trigger nonconformances every single time.
So the crucial point is this. When you look at the root causes of these nonconformances, whether it's missing criteria, supplier blindness, poor documentation, or inconsistent implementation, they all point back to the exact same underlying issue. They lead to a reactive, fragmented environmental management system. It essentially means the organization is operating on hope rather than true operational control. Which brings us to a final thought for you to consider as we wrap up this explainer. I really encourage you to look closely at your own operational blueprint. Are your environmental controls truly proactive, measurable, and verified across your entire supply chain? Or are you just waiting around for the next incident to happen? Thanks so much for learning with us today, and we'll see you in the next explainer.